All right, and this final application problem that I'm going to have you guys take a look at today, as long as the dog behaves, is about half-life of a substance. Now, in some of your science classes, you've probably heard about the term half-life. And when we're talking about the half-life of a substance, we're talking about the amount of time it takes for that substance to decay to half of its original amount. Now, in this example, it tells us that the half-life of lead is 22 years. So what that essentially means is if I have 100 grams of lead to start with, after 22 years, I'm going to be left with 50 grams. After another 22 years, or a total of 44 years, then it's going to go down to 25 grams. And so every 22 years, the amount is going to decrease by half. So the function that we use for this is still the n of t equals n naught e to the rt. So this question now has given us what the half-life of a substance is. And it has asked us how long it will take for the substance to decay to 80% of its original amount. Now, in order for us to do this problem, we actually have to find our decay rate. Because it's not half. We just know that the end result of it is going to be, after 22 years, we would have half of the amount. So in order for us to find our decay rate, we have to set up our function. Now, one thing that's missing from this function is the original amount. But the truth is, it doesn't matter what the original amount was. Now, if you are not given an original amount, the easiest thing for you guys to do is to say, hey, n naught then is going to equal 1. And then, for some reason, some of you might want to do n naught equals 100. And the reason for this is we know that after 22 years, that this is going to be half the amount. So it's going to be down to a half, or 0.5. This then would go down to 50. This one's always the easier one because it kind of allows you to skip a step. So I'm going to assume that I'm starting off with a unit of 1 something of lead. Now, if I do this, I have 1 times E to the R, but I do not know what my rate is. That's what I'm looking for. But I know after 22 years, it's going to decay to half its original amount, which would have been 0.5. And there she goes again. Now, what you're going to do from here is we're going to go ahead and just solve for R. Now, I know 1 times this, so I don't really have to pay attention to it. So when I go ahead and I take the natural log of that, I end up with the natural log of 0.5 equals R times 22. So now I know that my rate is the natural log of 0.5 over 22. So you better believe that I'm going to plug that into my calculator, and I have natural log of 0.5 divided by 22, and that is my rate. And now, do you guys see how this rate is negative? That's to be expected, because with a negative rate, that's telling us that we're looking at exponential decay. If this rate were positive, it's telling us that it's going to be growth. Now, I'm going to take this value and I'm going to store it into my calculator. So again, to store this, we hit store. So it's going to take my answer. And then I like to use R just for the sake of remaining consistent within the problem. So I'm going to store it as R. So that's done. So I'm going to make a note to myself somewhere in here, and I'm going to say, okay, R equals the natural log of 0.5 raised to the over 22. I'm way too into exponents right now. Okay, so I'm noting that is what R equals in the rest of my work. So my function now is going to be n naught e, and you can still look at it as this, times t. So here's our function that we're going to be using. But this problem didn't ask for just the function. It asked for the amount of time it would take for this to go to 80% of its original amount. So we should know a few things. We should know if the half-life is 22 years, it takes 22 years to get to half its original amount. So we should expect our rate to be between 0 and 22. Now, again, I don't know how much I'm starting with. So I'm again going to start with 1 because I know that 80% of 1 is 0.8. So my function in the equation that I'm solving for now, I'm just going to use r, is this. So what I'm going to do right now is I just now need to go ahead and solve for t again. Now, when I go to do this, I'm going to natural log both sides. So when I do this, I end up with the natural log of 0.8 equals RT. Well, I'm solving for t, so if I divide both sides by r, I'm now left with time. So I'm going to take out my calculator, and now I am going to do the natural log of 0.8 divided by, so if I asked you guys to round to the nearest tenth of a year, say, I apologize that that was not in the instructions, but to the nearest tenth of a year then, our time is going to equal 7.1 years. So it will take 7.1 years to decay to 80% of the original amount.